and I'm Lincoln. We'll introduce you to the automatic gate system. The smart automatic gate system is designed to open and close automatically when an object like a person or a vehicle is detected within a specific range. Using an ultrasonic sensor, the gate is moved by a servo motor and programmed by the Arduino Uno board. This enhances convenience, automation, and security. It offers touchless operation and demonstrates basic automation principle. It can be extended to real gates using larger motors.
In this automatic gate system, the Arduino acts as the brain of the entire operation. It receives signals, processes data, and controls the servo motor as based on the sensor inputs. Step-by-step working of the Arduino in the project. First, receiving signals from the ultrasonic sensor. The HCSR04 ultrasonic sensor is connected to the Arduino via 2 pins. The first pin is the trigger pin, which sends signals, and the second pin is the echo pin, which receives reflected signals. The Arduino sends a short high pulse to the trigger pin to emit sound waves.
Arduino calculates the distance using the time taken by the ultrasonic pulse and the speed of the sound. Continuous looping. Arduino runs in a loop, constantly checking the distance of the sensor and updating the motor position. Our logic is real time and does not need any manual input once powered. Optional addition. Use a serial monitor to display live distance reading during debugging.
Servo motor is a special type of motor that can rotate to a specific angle, usually between 0 degrees to 180 degrees, based on the control of signals it receives. In this project, the servo motor acts as an arm that physically opens and closes the gates. The servo motor has 3 wires. Each wire has its own color. The first wire is colored by orange, connected to the Arduino digital pin for the purpose of signal. The second wire is colored by red, connected to 5 volts for the purpose of power supply. And the third wire can be colored by brown or black, connected to the GND for the purpose of the ground.
The second one is the PWM signal from Arduino. The servo motor is controlled by the PWM, meaning pulse width modulation, a signal that tells the servo motor which angle to rotate to. The third one is the gate movement. The servo motor is connected to the gate arm or barrier. When the servo turns, it lifts or swings that make the gate to be open. After a short delay, it turns back to the closed position.
Ultrasonic sensor plays the eye role in this automatic gate. It detects the presence of a person, a car, or an object in front of the gate by measuring distance using the sound waves. The ultrasonic sensor has 4 main pins, which are VCC, GND, Trigger, and Echo. Their work is power supply, tragic signals, and echo signals outputs.
How the ultrasonic sensor works. First, trigger signal sent by the Arduino. The Arduino sends a high pulse for 10 microseconds to the trigger pin. It emits ultrasonic waves at 40 kHz to high performance to hear. Second, sound waves travels and reflects. The ultrasonic waves travels through the air until it hits an object, example a person or a vehicle. It bounces back echo towards the sensor. Third, echo received. The echo pin goes high for the duration the waves take to return. Uses the press-in function to measure. Fourth, distance calculation. This value tells how far the object is from the gate. Fifth, decision making. When the object is far or equal to 10 cm or any set threshold, it means something is in front of the gate. The Arduino triggers the servo motor to open the gate.
Servo includes servo library, which contains all functions to control servo motor by using Arduino. Servo creates a servo object named myServo, which sends rotations command to it. We also used INT post as a variable to hold the measured distance in centimeters from the ultrasonic sensor. This is a constant function that sends a sound pulse using the trigger pin, listens for echo using the echo pin, measures the time taken for the pulse to bounce back. This time is used to calculate the distance. Inside the red ultrasonic distance, we have pin mode. Pin mode sets the trigger pin to output mode in order to send signals.
In addition to that, pulse in echo pin measures how long the echo pin stays high time of flight of the sound waves. Void setup is once a start. Digital write is optional, not needed here unless something is connected to pin 12. myServo attach attaches the servo motor to pin 9. Zero begin is optional, not needed here unless something is connected to pin 12. Void loop repeats forever. Red ultrasonic distance use the distance using pin 6 trig and 7 echo. Centimeter 0.07123. Time converts microseconds to centimeters using speed of sound. If the distance is less than 30 centimeters, open the gates with servo motor 0 to 120 degrees. Wait 500 microseconds, close the gate back 120 degrees to 0 degrees, wait 5 seconds before checking back again. To rotate the gate, we had to power up the servo motor using a rechargeable battery, which is the one you can see. Uses the volts of 9 volts to 12 volts. That can power up the Arduino, which receives the signals from the ultrasonic sensor and commands the servo motor, which rotates the gate at 90 degrees after the object, which is the car, has been detected.
Thank you so much, sister, for your time, and thank you so much for sharing this innovative experience.
Thank you too, you are mostly welcome.